technically.
Finesse.
So a lot of you just put free throws, which technically that is what we're interested in, but we're interested in the true proportion of free throws that Cheyenne has made. I know, right? I'm going to abbreviate free throws as FT because I'm lazy. All right, Hayden's going to come give us the statistic. Thank you, sir. 33 out of 50, otherwise known as 66%. Anna is going to come tell us what Cheyenne's claim is and what the AP Stats class's claim is. It's okay, Anna. I'm more mad at Noah because I told Noah I wanted him to answer this one. And what does he do? He goes to the bathroom. Do we have, does the data provide good evidence against her claim? Yes or no? Yeah. Yeah. She says she's shooting 80%. Based on the data we have, it doesn't look like she's an 80% free throw shooter. She only got 66. It's not like she was at 78 or 79%. She was at 66, Cheyenne. What is your actual percentage, if you don't mind sharing? Do you know? That's not bad. That's good. All right, so this unit is all about hypothesis testing, significance tests. So today we're going to get some definitions. And hopefully by the end of today you feel comfortable with how to write hypotheses, right? Hypotheses. Is that plural? Hypotheses. That's just weird. This is, you guys will see our conclusion. See, and we'll get to write our first conclusion. And I gave you 4 lines. It's only 3 sentences, but they're lengthy sentences. All right, so like I said, some definitions to get us started. So a significance test is a formal procedure for comparing observed data with a claim. And we want to assess the truth of that claim. So we test it. Excuse me. A claim that is tested by a significance test is called the null hypothesis. And we have a special notation for it. It's a capital H, and then in the subscript we put a 0 or an O, whatever you want to call it. And we say H null. I have heard H naught. I think they use H naught in biology. Similar idea. but we say H null in this class. The test is designed to assess the strength of the evidence against the null hypothesis. Often the null hypothesis is a statement of no difference. The claim about the population that we are trying to find evidence for is called the alternative hypothesis. And we use a capital H, and then in the subscript a lowercase a. H alternative. The alternative hypothesis should always be created before you see the data. The alternative hypothesis is one-sided if it states that that a parameter is greater than the null hypothesis, or if it states that the parameter is lower. So alligators, greater than, less than, that means we're working with a one-sided significance test. It's two-sided, I can speak, I really can't. Two-sided if it states that the parameter is different from or not equal. Different from or not equal to. Meaning that the alternative could either be greater than or smaller than. Both the null and alternative hypothesis will refer to a population, not a sample, and therefore should be stated using parameters. If we're working with proportions, what's the notation for the parameter? That would be the statistic. The parameter is just P. And then if we're working with means, the parameter is what? Oh, thank you. When you're working with means, what's the notation for the parameter? Mu. Thank you. If you put p hat or x bar when you're stating your hypotheses, you will lose credit. Can I flip? All right, so some example questions of what you'll see in your homework. For each of the following settings, A, describe the parameter of interest. And then B, state appropriate hypotheses for a significance test. So number 1 says, according to the website sleepdeprivation.com, 85% of teens are getting less than 8 hours of sleep a night. Janie wonders whether this result holds in her large high school. She asks an SRS of 100 students at the school how much sleep they get on a typical night. And all 75%, I don't know why I threw percent on there, sorry, 75 of the responders said less than 8 hours. So are we working with means or proportions here? This one's kind of tricky because it talks about the mean amount of sleep they're getting, but since we're looking at 85% and 75 out of 100, we're looking at the true proportion of high school students at Janie's school who get less than 8 hours. I get less than 8 hours. Does anybody get more than 8 hours? Does anybody get 8 hours? On C days. On Wednesdays? When school starts later?
No, it's a good night when you get 6 hours of sleep.
True.
That's sad.
I would take 5, truly.
That's sad.
You guys are grumpy. So I would kill
Because of
6
school.
hours.
I put the symbol for less than because I was getting lazy. So then on part B, we're going to state our hypotheses. So we're going to state a null hypothesis. So we put H null, and then you put a colon. Now the claim from the website is that 85% of teens are getting less than 8 hours. So our parameter, because we're working with a proportion, we say P equals 0.85. The claim is that 85% get less than 8 hours. Janie just says she wonders if it holds true. It doesn't tell us whether she thinks less kids get 8 hours of sleep or more kids get 8 hours of sleep. It just says that she wonders if it holds. So our alternative, HA, would be that P does not equal 0.85. Since it doesn't specify that she thinks less than 85% of the kids get less than 8 hours, or that she thinks more than 85% of kids get less than 8 hours, we say it's not equal to. If we were to carry out this significance test, this is what we would call a two-sided significance test, because we have to test P being less than 0.85 and P being greater than 0.85. So you guys are going to try number 2. Part A, use words to talk about the parameter that we're looking at. Part B is more of, that's not words, more of math notation. Come up with what you think your hypotheses should be. You got this, Sam. Power of positive thinking. You got this.
What is it?
Believe you can, and you're halfway there. Hold it out, Maddie. Hold out your positive quotes to try and get Sam to do his math, but now he's just more interested in quotes.
You can't say true proportion for this one.
But, well, no, because you're not looking at proportions.
Yeah. So what do you say? True. True means?
Average.
Oh, yeah.
Average.
Who wrote this?
Yeah.
Yeah.
Deep. I don't fully person.
See? You're, if you see, you're halfway there. Thanks, Maddie.
You're welcome.
A is correct. What are you working? Mean is up.
Longer.
Yeah, but it's not P.
Wait, why did we do H null first? Then you say that we do
That's the claim. So you always start with the claim,
oh.
and then what you're gonna test to see if it's less than, greater than, not equal to.
I don't know. Maybe we'll find out later.
Yes.
I think I need a
But
word.
a mean or parameters from a sample. And we always state it as a
Would this be not equal?
This specifies the direction. You even underline it.
I'm just making.
No, you're good. I just don't like that extra. Okay, I thought you would like that. Should be up.
But the rest of them is right.
So which one of these can go do it?
I'll do it.
All right.
Yeah.
Thanks, ladies. All right, Jillian's gonna put A up for us.
Good job.
Sorry. It's okay. Thank you. And then Maddie's gonna do B. Yes.
So, I put average and expected, like parentheses. But would y'all be wrong if I said true expected amounts of time instead of true average amounts?
No, because expected value is another name for average.
Okay, I just want to make sure I wouldn't be wrong at that.
I'll be honest, I use the word mean because it's the shortest one to write.
That's fair.
Big brain.
I also use the word true instead of actual because it's shorter to write.
It's easy
You'll
to
see in a
memorize.
minute. I'm going to teach you some of my favorite abbreviations today because I'm lazy. I'm just lazy. To be honest.
I don't have time to debate this.
All right, so H null mu is equal to 10. HA mu is greater than 10. Since we're looking at greater than 10, that means it's a one-sided significance test. Any questions? Yeah, because greater than is what tells us one-sided. Less than is also one-sided. Not equal to is two-sided because I don't know whether it's less than or greater than. So I have two sides to test. Noah, do you have a question?
Do you have, is it like required to put one-sided or two-sided?
No. No.
So then how come we have to know?
How come you have to what?
How come we have to know if it's one-sided or two-sided?
Because it changes the way you do the test, which I'll show you later. Right now we're just learning like the basics. Eventually I'll teach you how to do the test. Anna, do you have a question?
Can you just like explain the one-sided, two-sided thing?
So one-sided is if you're saying it's greater than, because eventually we're going to be looking at normal curves, and greater than is to the right. Sorry, thinking backwards. So that's only one side we'd be looking at. If it says less than, that's to the left. We're only looking at one side of the normal distribution. If it says not equal to, it doesn't tell me whether I want to look at less than or greater than, so I have to look at both.
Okay.
So it's two sides. Any other questions? All right, a few more definitions. The probability computing. Okay, start over. The probability, which is computed when we're assuming H null is true, that the statistics such as p hat or x bar would take a value as extreme as or more extreme than the one actually observed is called the p-value. The smaller the p-value, the stronger the evidence against H null provided by the data. I almost said provided by the evidence, sorry. If the p-value is smaller than alpha, and alpha, by the way, is the fish-looking one. Yeah, but you also, isn't Greek one of the languages that you've taught yourself? So yeah, there you go. All right, so alpha is the fish-looking one. So if your p-value is smaller than alpha, we say that the data are statistically significant. At level alpha. In that case, we reject the null hypothesis and conclude that there is convincing evidence in favor of the alternative hypothesis. Yes, I've had kids in the past, they're like, it's a very negative way to say things, and it is. You have to say you reject the null, or you fail to reject the null. You never say you accept the alternative.
You have to reject.
You have to reject or fail to reject, all negative words.
That signal line.
Alpha, by the way, is usually 0.05 unless stated otherwise. If there is no statement about the alpha level, you use 0.05.
What is that? The green.
Alpha? Alpha.
Fish?
Alpha, yes. Alpha is the fish-looking one.
Alpha equals fish. I think fish are alpha. It's alpha and 8 fish.
Once we assess the p-value compared to the alpha level, we have two choices. The first choice is to reject H null. We do that when our p-value is less than alpha. The other option is fail to reject H null, which comes up often enough that I was taught an abbreviation for it by a grader of the AP exam. So if you put this in your AP exam, they do know what it means. FTR, fail to reject H null. We do that if our p-value is greater than or equal to alpha. So, in summary, taking what I said up here along with our two choices down here, if the p-value is less than alpha, that means we have strong evidence against H null. That made me feel really good about my lesson. Thanks, Zach. It's okay. It's Friday. I think we're all tired by now. I just had to pick on you because it was a big yawn. And if we have strong evidence against H null, we're going to reject H null. And if we reject H null, we conclude the alternative. And of course, my big handwriting. Running out of space. Am I still on the board?
No.
Poopers, scoopers. Sorry.
So stinky.
It says conclude. I hit this side of my paper, so it looks funny. Strong evidence against H null, which means we reject H null, which means we conclude the alternative. The other one, p-value is greater than or equal to alpha. That means we have weak evidence against H null. And if we have weak evidence against H null, we're going to fail to reject H null. And if we fail to reject H null, then we cannot conclude the alternative. See, it's a very, all the words have like negative connotations. Very weird. But you have to do it this way. On the AP exam, if you write except HA, accept the alternative, they won't give you credit. Was that your question?
No.
What's your question?
What is the significance of alpha? Is it like a constant or comparative relationship? What is it?
Pretty much it's the probability.
Okay.
Because we're, like I said, we're eventually going to be looking under normal curves. And so our normal curve will be drawn based on H null. And then our value that we're looking at, whether it's less than or greater than, is based on the sample. We're actually going to do one in a minute. And so you're finding the probability that if H null is true, you use that parameter in the standard deviation. What is the probability that you get the statistic you got? And if it's less than 5%, then it's statistically significant that the claim probably isn't true. Because if it's less than 5%, it probably didn't just happen by chance. There's other factors that are affecting it.
So alpha is related to statistical significance?
Other questions? All right, so we're going to go back to picking on Cheyenne. Yes, it does look very similar to the warm-up. What's our parameter of interest? True proportion of free throws that Cheyenne has made. Hayden, what was our statistic?
33 out of 50, 66%.
Thank you, sir. I am going to leave it as a decimal, though. And because it's our statistic, we use p hat. Anna, what was Cheyenne's claim? 80%, and that really is our null hypothesis. And then the AP statistics class claim was what, Anna?
Not very good.
She's not that good, which would mean less than, greater than, or not equal to. Less than. So we claim that she's probably less than an 80% free throw shooter. So that's the alternative. So on the warm-up, we just said, does the data provide good evidence against Cheyenne's claim? Now what we're really going to ask ourselves is, if we assume Cheyenne's claim is true, how likely is it that she would get a p hat equal to 0.66 or lower, because we're looking at less than, so we say or lower, purely by chance. And purely by chance, remember, was something that came up in probability, and I said it comes up enough that I don't want to write it. Well, I don't like to write it in this unit either. And by the way, most of my abbreviations were taught to me by an AP scorer. So if you get in the habit of using them, they tend to know these ones if you put it on your AP exam. So don't freak out that I'm teaching you things that aren't going to be known. Nate?
Does the P in HNL and HA, does that mean proportion or P value?
Proportion.
Okay.
That's why we literally put P value.
Okay, so if we ever want to talk about P value, we write out P value.
Yeah. Unfortunately, P is a popular letter in statistics. All right, so we're going to do a simulation to answer that question and figure out whether Cheyenne's claim is true or not. We're actually going to look at two of them. So I'm going to draw a dashed line through here. Everybody got a calculator? Pull out your calculator. Anybody need a calculator? Just two?
I'm lazy to plot accurately.
1 Every class period. Sometimes I really wonder what is going on over there.
It's like the 90s. Yeah,
What's
they
going
really
on then?
yellow
If we don't use your
What?
classroom,
No, I gave them all out on test day. Sorry. All right. So, like I said, we're going to do a simulation. So, Cheyenne took 50 free throws. And she claims that she's an 80% free throw shooter. Oops. There we go. So we're gonna use our random digit generator, which means that we have to specify what numbers mean she makes the shot and which numbers mean she doesn't. So if she's an 80% free throw shooter, we could use the numbers 0 through 9, because that's 10 numbers, right? And we're going to say 8 of them mean she makes it, and 2 of them mean she doesn't make it. Everybody okay with that?
what is the 50 foot
50 free throws.
for?
That's how many she took.
My bad.
Sorry. So let's use 0 through 9, because that's 10 numbers. Anybody care what numbers mean make or miss?
Yes, name should be 5 and
Make should be what?
5 and 3.
You mean miss should be 5 and 3. You're really going to make this difficult, aren't you?
Yes.
Okay.
This is 5.
Miss, 3, and a 5, which means make is 0 through 4. No, 0 through 2, 4, and 6 through 9. Oh, gosh.
Why did we?
Nate!
Why couldn't we just pick 1 and 2?
Make
So-
life interesting.
True.
No.
So, you're going to, in your calculator, use your random digit generator, rand int. If you have an older calculator, it doesn't prompt you, but it wants to know the lowest number, the highest number, and how many numbers you want. And we want 50 of them. Since Nate picked 3 and 5 to mean miss, it might be easiest if you count the number of 3s and 5s that show up. Remember, if you have an older calculator, may I borrow yours, Joanne? Where's your calculator?
We got a random.
Math, prob, number 5.
Oh.
So you put 0, 9, 50. Did it literally just die on me?
Oh.
It should turn on if you, yeah. It said that for like 2 weeks, but it still works.
Yep,
It's incredible.
it
Gotta
is.
die on
Oh, I'm sorry, this is
No,
wrong.
it's okay.
you. It actually
I
died.
just want to remind you that you can't scroll up,
Yeah.
because if you scroll up, then it freezes your list. So there's your list. There's Maddie's list. If yours is an older one, do not go up and highlight it, because it will freeze the list and you won't be able to read it. Just stay where you are and scroll to the right. So I would say it'd be easiest to count the numbers of 3s and 5s that you have, subtract from 50, figure out what your sample is.
I have 2.
Yeah, you can't highlight the list. You have to re-enter it.
So what?
It's one of the dumbest features I have ever seen.
Oh, I just
Yeah,
saved this one.
now don't go up, just scroll to the right.
It's so dumb.
It is one of the dumbest
Let's see
features
Texas
about
Instruments.
the TI I've
Get money.
ever seen.
I know, it's so
So,
I don't even
silly.
know.
Where's your,
Was it at 3 or 4?
it's a 5 and a 3.
Oh.
Sorry.
It's okay.
I don't know what I'm doing.
So are we just
Honestly,
counting?
same.
Yeah, count how many she made out of 50. Well, count the 3s and the 5s, subtract from 50. It's probably easier.
Wow.
Yeah, this is.
2 minus 50.
But you count how many makes
48.
it. So you just count.
She made
55.
48 pounds? Really? Are you sure?
Oh.
Did you scroll through the whole list?
You did it.
3s and
There's
5s.
They only gave me 10 numbers.
You can't highlight it. That's what it just said.
Oh.
If you highlight it, it will freeze the list and you can't read it.
Oh. Okay.
Really, only 8?
Okay,
And then.
Uh-huh.
Okay.
Well, that means.
I see what you're talking about.
Yeah, it's the dumbest feature I've seen on the TIs.
Now I understand your frustration. I was like, yeah, go on. But now I'm like, you know what? Yeah, that does something.
I lost track
We made it so we can do 3 and 5 on.
It's really bad, right?
Oh, it's not that hard.
It is. It's so hard. Oh, I lost track. It's okay, I'll extrapolate the data.
Do better.
All right. So I'm gonna call on you guys. You should hopefully have your p hat. Mine was 39 out of 50, which is 0.78. So I'm gonna put a dot on our dot plot. Sam, what was your p hat? No. Sam, you and I tend to get a lot of the same answers. Jillian?
0.76.
It might have been 40 look.
Maddie?
0.86.
Haley?
0.82.
Shelly?
0.84.
Hannah?
0.88.
Damn,
Zach?
0.76.
Amelia?
0.88.
Tyler?
0.84.
Hayden?
0.7.
Somebody had to be down there.
Oh,
Nate?
shame.
Nate?
0.78.
Thank you.
That's sus.
Calvin?
0.76.
Anna?
0.8.
Noah? Oh, sorry, I skipped Bianca. I was going up and down rows. And then
I haven't done mine yet.
Bianca? Say it again. You froze your list. Cheyenne?
Oh, do 41.
Yeah, did you have 9 3s and 5s? Is that what you're saying? So she missed 9 shots, which means she made 41.
Yeah.
So 82. And then Cheyenne? 8.4? See, Cheyenne is better than 80%. Noah, you got yours? No? All right. So, how many of our data points were 0.66 or lower? None. All right, here's 0.66. None of them were lower. That was when we assumed her claim was true. There are what? No, I didn't do it. So 3, 6, 9, 12, 15. I make 16. So 0 out of 16 of our data points were lower. Bless you.
Bless you.
So none of them were lower than 0.66, which means that for this simulation, our p-value would be 0. Because 0 out of 16 is just 0. So based on that p-value, it's less than alpha, which means that there is strong evidence against H null, and we would reject it.
Yes.
Now, you're not going to do a simulation like that for every claim. What you would do otherwise, and what we'll eventually do, is we're going to look at the normal distribution. She took 50 free throws, right? And we can check that n times p is greater than or equal to 10, n times 1 minus p is greater than or equal to 10, so that we can assume it follows a normal distribution. So over here, we're going to use our knowledge of normal distributions to find the p-value. So like I said earlier when Nate had a question, I said we draw our normal distributions based on H null and assuming it's true. So H null, 0.8, that was the assumed claim. So that means we have 0.8 at the center here. Standard deviation. Anybody remember that standard deviation formula for proportions? Square root but because we're working with a claim here, we're going to use p instead of p hat. So our standard deviation is going to be 0.8 times 1 minus 0.8. She took 50 free throws, so n is 50, and then we square root it. So 0.8, 1 minus 0.8 is 0.2. Then I'm going to divide that by 50 because she took 50 free throws. And then square root my answer. So we get 0.057 if I round. What am I waiting for? I put 0.8 in for P and 50 in for N. And that's how I got that. So then I can draw the rest of my curve. We go 3 standard deviations above and below. Oh, my brain is not in subtracting, adding mode. So 1 standard deviation below is 0.743. Then it's 0.686. And then it'd be 0.629. I can add, that'd be 0.857. Know that one. This would be 0.914. And this would be 0.971. So assuming that Cheyenne's claim is true, she's an 80% free throw shooter. She went to the gym, she took 50 shots, and she got a p-hat of 0.66. So we're going to look at how likely it is that she would get p-hat of 0.66 or lower, because we're looking at our alternative being less than, purely by chance. So 0.66 is somewhere in between these two, probably closer to the 0.68. So I'm going to say like there. So here's 0.66. And we're looking at it being less than, so we want to find this area under our curve. Normal CDF. Lower bound is going to be some small number. like negative 1E99. Upper bound, 0.66. Mean, 0.8. Standard deviation, 0.057. And then we're going to find the probability that she got 0.66 of her free throws made or less purely by chance. So normal CDF, remember, is second bars, number 2. And when I put that in, I get 0.007. So our simulation actually was pretty close because 0.007 is less than 1% of the time. So we get a p-value equal to 0.007. So it seems really unlikely that if Cheyenne really is an 80% free throw shooter, that she would have gone to the gym and shot 66% or less. Any questions? Nate?
On like a test or homework, would we use the second method all the time?
Yes. If there's actually going to be calculator functions that will, because based on whether it's a proportion or a mean, it's going to change between a z-test and a t-test. So I will teach you that later. Right now I'm hoping to get the basic idea down of what those things do. So that when I teach it to you, you don't just think it's something the calculator magically does. Other questions? All right, so now we get to write a novel. I know, right?
I've written it so long. I missed it.
All right, so we're going to write our first conclusion.
Amazing.
With significance tests, we'll have state plan do conclude, just like we did with confidence intervals. This is the conclude part. So going back, Cheyenne says she makes 80% of the free throws. We just got a p-value of 0.007. So anytime you're writing a conclusion, the first thing you want to state is assuming H null is true. Because everything is based on assuming her claim is true. And it's best if you put what H null is in parentheses. Then we talk about our p-value. And like I said, our p-value really is the area under the normal curve. So really it's telling us the probability that that situation is happening. So we're going to say there is a 0.007 probability sorry, off the board, of getting a p-hat less than or equal to 0.66. That was our estimate from the statistic, purely by chance. And this is where I abbreviate, because I'm already going to write a lot. So I stated that we believe H null is true. I gave my p-value and my statistic all in that one sentence. Yes?
So should we not interpret this one in context? You just say
We're
there's this
getting there.
probability?
We're getting there. Say that again? Okay. Then we go into talking about back here, if p-value is less than, I don't know what is wrong with my camera today, but it is not where I'm used to it being. If p-value is less than alpha or p-value is greater than or equal to alpha. We got 0.007 for our p-value. Alpha is 0.05. So we're in this first situation. So we're just pretty much going to put those three things into a sentence. This provides strong evidence against H null. And then we want to say something like that's because our p-value is less than alpha. You can either say it in words or you can use the actual numbers. And is statistically significant. At alpha equals 0.05. Therefore, and I use my little triangle thing, therefore, we reject H null and conclude HA. And this is where context comes in. We would say the true proportion of free throws made by Cheyenne is less than 0.8. And I'm sure that you guys can probably wordsmith it better than me. I will tell you, I was taught these sentence frames by an AP scorer, but if you guys write them this way on the AP exam, assuming you put the correct information in there, you will get full credit for your conclusion. I know the test was different in 2020 because that's when COVID hit and they had to scramble to make things work. But my students absolutely hated having to write these conclusions, and over half of the free response questions were just analyzing conclusions for mistakes. So as much as you're going to learn to hate it, it is a good thing to learn, especially if you're taking the AP exam. Any questions? All right, now we're going to assume that we got a different p-value so that we fail to reject, and see what it looks like when we write one that way. So we're going to change things up, and we're going to say, suppose that Cheyenne had made 37 of the 50 free throws. That changes your p-hat. So it would change where we drew on our normal curve back here. It's going to change the p-value. I already did it for you. It gives you a p-value of 0.144. which is greater than alpha, so it changes our conclusion. That way you guys can see both ways you write a conclusion. Both ways start by saying assuming H null is true. And we go on to continue just like we did up there. We say there is a, then we change. We don't have a p-value of 0.007 anymore, it's 0.144. So we say there is a 0.144 probability of getting a p-hat, and that changed also. So 37 out of 50, that'd be what, 0.74? So we're going to say p-hat less than or equal to 0.74 purely by chance. So notice it's very similar. Just a couple things changed. Our p-value changed, and our estimate, our statistic, p-hat changed. Then it changes a little more here because our p-value is less than alpha. So we say this provides weak evidence against H null. Because our p-value is greater than or equal to alpha. 0.144 is greater than 0.05. And is not statistically significant. You guys okay if I abbreviate statistically significant as stat sig? Okay, good. Thank you.
What if we said no?
I would have written it out, but my hand would have hurt more. I'm sure yours would have too.
Wait, what is statistically significant?
0.05. Anything less than that would be considered statistically significant. Because there's less than a 5% chance it just happened by chance. There has to be a reason it happened. Yes?
Will questions sometimes change alpha? Or is it always
Yes.
alpha?
Sometimes they will do as low as 0.01. But if it doesn't specify an alpha level, you go with 0.05. So if it's not statistically significant, we would say that we failed to reject. So therefore, we failed to reject H null. And cannot conclude the alternative. And that's where our context comes in right at the end. Cannot conclude HA, the true proportion of free throws. Not gonna fit that word there. Made by Cheyenne is less than 0.8. see it as a novel. But it's very much the same, just a few tweaks each time.
What's FTR meaning?
Say that again.
What does FTR mean?
Failed to reject.
Oh.
Never mind.
Never mind.
I don't know why it's a question.
Questions? No? All right. I think we'll stop there. This one was just to show you that the same type of idea can be done using means, because this was about the mean age. And then it was just your exit task. So maybe you can try your exit task. No? You want me to go back? Sorry.
Did you make a question about yourself?
I did make a question about myself.
Nice.
Why wouldn't I want to make a question about myself?
If I was a teacher, I'd make a question about myself.
Can I get my test?